Why is the ocean salty? A deep dive into nature's chemistry. Welcome to Clear Up, Misunderstood Facts, the podcast where we challenge what you thought you knew and explore the truth hidden beneath common beliefs. Today's episode is going to take us on a journey that is vast, ancient, and, well, salty. We're answering a deceptively simple question. Why is the ocean salty? It's a question many of us asked as kids and probably never got a satisfying answer to. After all, rivers flow into the ocean and rivers don't taste like salt water. Rainwater isn't salty either. So how did Earth's oceans become a giant basin of salt? In this episode, we'll explore where the salt comes from, why it stays in the ocean, whether oceans are getting saltier, and what this means for marine life and even human history. Let's dive in. Where does the salt come from? The short answer is, salt in the ocean comes from rocks on land and volcanic activity under the sea. Here's the long answer. Rain isn't just water, it's slightly acidic because it absorbs carbon dioxide from the atmosphere, forming carbonic acid. When this slightly acidic rain falls on land, it begins breaking down rocks, a process called weathering. As rocks break down, they release minerals, including salts like sodium and chloride, the two elements that make up common table salt. These salts get washed into streams and rivers and eventually flow into the oceans. This has been happening for millions of years, so even though the amount of salt carried by a single river in 1 year is small, over geological time it adds up. The oceans have had a long time to accumulate salt, we're talking billions of years. Now here's the key part. While water from the ocean evaporates to form clouds and rain, salt does not. So, over time, as water leaves the ocean and comes back as fresh rain, the salt remains and keeps building up. But that's not the only source of salt. There's also hydrothermal vents underwater volcanic openings, found along mid-ocean ridges. These vents spew superheated water that has circulated through the Earth's crust, dissolving minerals and adding more salts directly into the sea. Plus, undersea volcanoes erupt and release additional minerals that contribute to the ocean's saltiness. So, to recap, the salt in the ocean comes from land via weathered rocks and from beneath the ocean floor via volcanic and hydrothermal activity. Why aren't rivers salty? Good question. If rivers carry salt to the ocean, shouldn't they be salty too? The answer lies in concentration. Rivers do contain dissolved salts, but they are much more diluted compared to the ocean. The concentration of salt in rivers is so low that we don't taste it the same way we do with seawater. On average, ocean water contains about 35 grams of salt per litre, that's 3.5% salinity. In contrast, rivers usually contain less than 0.5 grams per litre, or less than 0.05% salinity. Because rivers are constantly replenished by fresh rainfall and runoff, the salts don't accumulate like they do in the ocean. And as rivers flow, they drop some of those salts into soils, are absorbed by plants, or chemically interact with the surroundings before ever reaching the sea. But once that salt does reach the ocean, it tends to stay there. Why? Because the ocean has a very stable salt budget. And that leads us to our next big question. Why doesn't the ocean get saltier? You might be wondering, if salt is constantly being added, why doesn't the ocean just keep getting saltier? Great question, and the answer involves a balancing act. While salt does accumulate in the ocean, it also leaves the ocean in various ways, though much more slowly. For example, some salts are removed when marine organisms use them to build shells and skeletons. Salt can get buried in sediments on the ocean floor. Chemical reactions on the sea floor can trap some minerals. However, these processes remove salt much more slowly than it's added. That's why the ocean is salty, but not becoming endlessly saltier. Interestingly, scientists believe that the ocean reached its current level of saltiness millions of years ago. The system is now in a kind of equilibrium, with salt being added and removed at a relatively steady rate. Are all oceans equally salty? Not quite. Salinity varies across the world's oceans based on a few key factors. Evaporation. In hot, dry areas like the Red Sea or Persian Gulf, evaporation is high, and less fresh water comes in, making these areas saltier. Precipitation. Rain adds fresh water and dilutes salt concentration. Tropical rainy regions have lower salinity. Ice melting or freezing. When sea ice forms, salt is left behind, increasing local salinity. When ice melts, it adds fresh water and decreases salinity. River input. Large rivers like the Amazon or Ganges freshen the surrounding seas. So the open Atlantic Ocean is generally saltier than the Pacific, and places near the equator or near polar ice caps often have different salinity levels due to climate factors. How salinity affects marine life. Salinity plays a huge role in marine ecosystems. Most ocean creatures are adapted to a certain range of saltiness. For example, coral reefs thrive in stable salinity environments. Some fish, like salmon, are adapted to live in both freshwater and saltwater at different life stages, but they undergo a complex physiological shift to do so. Changes in salinity, whether due to climate change, melting glaciers, or pollution, can disrupt ecosystems, migration patterns, and breeding behaviors. Salinity also influences ocean circulation. Saltier water is denser and sinks, helping drive the Great Ocean Conveyor Belt, a global system of currents that distributes heat and nutrients around the planet. Why it matters for humans. Saltwater has shaped human history. Ancient civilizations harvested sea salt for trade and food preservation. Coastal towns grew up around salt mines and evaporation ponds. Wars have even been fought over salt routes and resources. Today, understanding ocean salinity helps us with climate modeling. Salinity impacts temperature regulation and current patterns. Desalination technology, removing salt to provide fresh drinking water to arid regions. Predicting weather. Ocean salinity influences rainfall and storm formation. Could the ocean ever become too salty? Theoretically, if the water cycle were disrupted, say, less rain, more evaporation, or changes in global ice salinity could change over time. But Earth has a robust water cycle that maintains relative balance. Still, scientists monitor salinity trends as part of climate change research. There are even lakes on Earth, like the Dead Sea or Lake Assal, that are much saltier than the ocean, up to 10 times saltier. These are closed systems where evaporation far exceeds inflow. The ocean, being an open system with rivers, rainfall, and currents, is much more stable, but long-term changes in salinity can signal deeper shifts in climate. Conclusion. So, to wrap up, the ocean is salty because of millions of years of water flowing over rocks and carrying dissolved salts to the sea. Volcanic activity beneath the ocean adds to the mix. And because salt doesn't evaporate with water, it accumulates. It's a story of chemistry, geology, biology, and time, and it's still evolving. The next time you dip your toes in the sea or taste a salty breeze, remember, you're part of a cycle that's been turning for billions of years. Thanks for listening to Clear Up Misunderstood Facts. If you learned something new today, leave us a rating, follow for more episodes, and share with a friend who loves a good science mystery. Until next time, stay curious.